So we are going to start a new chapter. And I know this graph paper looks a little bit intimidating, but this is polar graph paper because our next chapter is polar equations. So we're doing an introduction to polar coordinates today. So we're just going to dive right in. And it looks intimidating, but it really isn't. So don't be too fearful here. So we typically always work in Cartesian coordinates. That's what we've done: algebra, geometry, most all of pre-calc, right? We use Cartesian coordinates. And what the heck is Cartesian coordinates, right? You're like, we've been doing it, really? I don't know that we've been doing it. Yes, Cartesian coordinates is a fancy name for x comma y, right? And all x comma y is, it's directions, right? It gives you a distance to go from the origin to the right or left. That's our x coordinate, right? And then our y coordinate tells us how much to go up or down. So it's just directions to a coordinate or to a point. So I'm going to write that down. Directions to a point. All right, and now we're saying, okay, now we're going to do it in a different way. That's all. We're just going to do directions differently. So in polar, instead of giving an x direction and a y direction, we still start from the origin, and then now we're going to, let's say we have this same point out here, we're going to give a distance from the origin, and we call that an r value. I think it's for radius, I'm assuming. And then we're also going to give the angle, r and theta. So, and we write it the same way we wrote our Cartesian coordinates. We write r first and then our theta second, and we write it in parentheses with a comma in between them. That's it. That's polar coordinates. So let's say, like on your homework tonight, they're going to give you some points to graph. So let's say we're going to graph point A is 2, 150. Point B, 3, pi over 2. C, 1, pi over 4. And let's do D for 600 degrees, say. Right? Okay, so now you can see using polar paper is helpful because these concentric circles represent different r values, right? So just like when we have x and y, we would do our graph paper, we would label it. So we can label this 1r, and then this would be 2 because the distance is 2 from the origin, 3, 4, 5, 6. So you can see each concentric circle represents a different r value or a different distance from the origin. And then this nice, it's got all the, or most of the angles that we would want on here. And notice this happens to be in degrees, but that doesn't phase us because we can convert, right, from degrees to radians, no problem. Okay, so this one tells us an r of 2 and an angle of 150. So we're going to go out here to 2 and then go around to 150, and this is labeled right here, and we'll just put our dot and label it A. Easy peasy, right? Okay, you try to do the next ones and I'll follow along, right? Okay. All right, so now we're going to go to 3, and we know pi over 2 is 90 degrees, so I'm going to go to the third one and 90 degrees. D. C is only on the 1 right here, and it is pi over 4, which we know that's 45 degrees. So this one's kind of weird because 45 degrees isn't a line on here, but we know it's exactly halfway in between 0 and 90. So it is right here, see? And D is out here at 4, but it's 600 degrees. So what do we do with 600 degrees? It's obviously not on here. Yeah, we would subtract, right? We're going to subtract 360 from 600. And then we'll know how far around. So we're once around, right, is 360. So we're just going to subtract 360, and we'll see how much further around. We'll go around once, and then we'll go around again, right? So 0, let's do that, 0, and we borrowed here, we borrowed 9. A 9 minus 6 is 3, and then we borrowed, so 230. Okay, so that's pretty easy. So we go out 4, and we're going to go around here to 230. So this is 210, 220, 230. And we're right here. And we'll label that D. Okay, so we actually went around twice, but you can't see that. Nobody can see that, right? Okay, we're good with graphing, hopefully. Okay, now what's going to happen? A lot of times they give us negative angles. That's okay. Negative values. Well, actually, they can give us negative angles and negative R values. So we'll talk about what that means. So for negative and positive theta, you guys know this already just from doing trig and the unit circle and stuff. So if we go this way, counterclockwise around the circle is, yeah, you got it. Positive theta is counterclockwise, opposite directions of the hands of the clock. And if we go this way, clockwise, that's a negative theta. So that's clockwise. Okay, now the big difference here, which we didn't know, negative R goes backwards. And you're like, what does that mean? So negative R goes backwards. So I'll do a couple of examples. Backwards, that's not right. Okay, backwards. Backwards. Okay, that's important. But you're like, what does it mean? All right, so let's do one that's easy that we already know. Let's do A. Here is going to be 1 comma negative 30 degrees. Okay, so 1 is here, and then a negative 30 is going to go down this way, and it's at the 330 line, right? So that's A. Okay, easy peasy, right? Let's do another one in radians, just so you know, right? Negative 11 pi over 6. Now, you guys know 11 pi over 6 would be right over here, right? However, if we go negative, we're going to go around this way and end up at 30 degrees. And we have to go out 5. So let's count that. 1, 2, 3, 4, 5. There we go. So that's B. Okay, now let's do a negative R value. So negative 3 for R and negative 60. Okay, so for negatives, what I do is I find the angle first. So negative 60 is going to be this way. It's going to be at 300, right? And normally we would be going, positive R would be this way, 1, 2, 3. Guess what? Negative R, you're going to go backwards. So it's going to be 1, 2, 3. C. Cool, right? Hopefully that's not too confusing. So for these, I'm going to put a little thinking bubble. Negative R goes backwards, and then underneath it I'm going to write, what should we write? Do the angle first, and then do a negative R. So do angle first, then go backwards, then negative R. I think that makes sense. Okay, let's do D. Let's do one more. -2, -300. Okay, now I'm gonna kind of give you a minute. You try this one, see if you can do it. All right, how'd you do? All right, negative angle, so we're going to do a -300 degrees, which is all the way to 60 here, right? And then instead of going out +2, we're going to go back 1, 2. Did you get it? I bet you did. All right, we're going to do the next part in the next video.